The human brain, a complex marvel of 3 pounds of neural tissue, constantly processes a deluge of sensory information from sights, sounds, and touch, seamlessly integrating perception and memory in perfect harmony. In normal perception, sensory inputs like visual scenes and auditory cues flow first through the thalamus to specialized cortical areas such as the visual and auditory cortices, then simultaneously to the medial temporal lobe for processing. Here, the rhinal cortex quickly assesses familiarity of the input, while the hippocampus encodes detailed episodic memories, ensuring synchronized perception and memory formation with latencies under 200 milliseconds. Suddenly, a powerful sense of familiarity emerges without any true matching memory, as the brain erroneously mislabels the unfolding present moment as a fragment from the past. This intriguing experience is known as déjà-vu, French for already seen, a common neurological phenomenon affecting 60 to 70% of people, especially ages 15 to 25, where a new situation feels overwhelmingly familiar despite knowing it hasn't occurred before, typically lasting 10 to 30 seconds. Studies, such as in Cleary's 2008 experiments at Colorado State University using rotated scenes to induce spatial familiarity without context, show that a high familiarity signal from the rhinal cortex activates without corresponding hippocampal recollection, creating this compelling illusion. At the intracellular level within the hippocampus, the error arises from desynchronized neurotransmitter release, particularly glutamate and GABA, in pyramidal neurons of the CA1 region. Normally, long-term potentiation strengthens synapses over 10 to 100 milliseconds through coordinated calcium influx, but in déjà-vu, premature dendritic spine activation occurs 50 to 100 milliseconds too early. This premature activation triggers false memory retrieval circuits several milliseconds ahead of schedule, before the current sensory perception has fully consolidated in the neural networks. The hippocampus, specifically the CA1 region, with its place cells and grid cells from the entorhinal cortex, falsely flags the current perception as a match to a stored memory engram. Conscious awareness in the prefrontal cortex then follows with a delay of 300 to 500 milliseconds, as shown in fMRI studies like Harper and Brewer's 2012 research, creating the vivid illusion of prior experience. This makes the sensation feel incredibly convincing and real, because the familiarity signal propagates swiftly via the perforant path in about 20 milliseconds, faster than the slower detailed recollection processes. The memory system activates first, engaging the default mode network across brain regions, which convinces the prefrontal cortex of the memory's authenticity before any discrepancy detection mechanisms can intervene. As inhibitory interneurons, acting like delicate circuit stabilizers, restore synchrony by dampening excess activity, the neural timing gradually realigns, and the intense sensation of déjà vu begins to fade. Theta oscillations at 4 to 8 Hz then realign the hippocampal circuits within 1 to 2 seconds, returning the brain to its normal, harmonious processing. This benign glitch is more common in temporal lobe epilepsy patients, up to 80%, or during fatigue and stress.